These are the in-class notes on Chapter 4, which primarily focus on creating an ogive. This page has a lot of terminology, but hopefully some of it will be familiar or just make sense. Okay, so to start, frequency are the counts of the number of seasons where they hit that number of home runs. Okay, when we talk about relative frequency, okay, we just take this number and we switch it to a percentage. So 2 over the total number of seasons. Now, when you look at the bottom of a table and you see a number in a box like that, this 16 is just the sum of all of these frequencies. Okay, this 100% is just the sum of all those relative frequencies. Cumulative frequency, cumulative means that we're just adding all those up. Okay, so our first class has 2 in it, our second class has 1. The cumulative frequency up to that point is 3 because so far we've passed 3 frequencies, okay, out of the 16. This next one, the cumulative frequency is 5 because at this point we have 2 plus 1 plus 2 is 5. Once we get to the bottom of our cumulative frequency, okay, this number should always match whatever our total cumulative frequency is. And then relative cumulative frequency, anytime you see the word relative, relative just means take that number and switch it to a percentage. So 2 over 16, 3 over 16, etc., etc. The last type of graph is spelled O-G-I-V-E. It's pronounced ogive. And it's used with either cumulative frequency or relative cumulative frequency. Here we're going to do it with relative cumulative frequency. And it's counting the percentage of the data that we've passed at any given point in our data set. So every ogive starts with the leftmost number in our first class. So in other words, how much of our data have we passed by that first number, okay? Or put another way, in how many seasons, percentage-wise, did Barry Bonds hit less than 15 home runs? And the answer is 0. Okay, now we move on to this next one. Okay, and how many seasons did Barry Bonds hit less than 20 home runs? Okay, up to including 20 home runs. And that would be this number right here. He's hit 12.5% of his seasons. He's hit less than 20 home runs, okay, which would be this dot. Okay, next one would be 25. And how many seasons did he hit 25 or less home runs? 18.75, which would correspond to that dot, on and on, until we get to the very last number in our frequency table. Okay, there's actually 2 here, and both those numbers go on. So we can see 70. By 70, okay, once he's past 70, he's hit 93.75% of his seasons, he's had 70 or less home runs. And then this last season, he hits his last most successful season. All right, so we put this last number to round off that ogive. That's this last dot right here. Once we have our ogive created, we can answer a number of questions about it. For example, what's the relative standing of a season in which Bonds hit 40 home runs? Well, if we were to look at this and trace up from the bottom, which is the home runs, which is about here, and trace that over. Okay, it looks like that's at about 65%, right? So that would be the 65th percentile. Okay, next question, how many home runs must be hit in a season to correspond to the 75th percentile, right? So we're going to do the same thing, except now we're going to move from the 70 over. Okay, so about here, trace it down, and it looks like that would be about 45. What can go wrong? Now this applies to the whole chapter and not just the in-class portion of the notes that we covered in this PowerPoint, which was just on ogives. So to start, don't make a histogram out of a categorical variable. We would only use bar charts or pie charts for a categorical variable. And if you make a bar chart, be sure to put in those spaces in between the bars. That's how we know it's a bar chart and not a histogram. The reason those spaces are there is because it's okay for bars to move around in a bar chart. It's not okay for bars to move around in a histogram. It wouldn't make any sense to take this bar and put it over here, okay, or right in the middle of those. Don't look for shape, center, and spread of a bar chart. SOX is only used for quantitative variables. And make sure we use a scale that's appropriate to the data. Both of these graphs are for the same data set. You can see how much that shape changes depending on what we use for the width of those bins.